Welcome everyone. In this video I will take few more problems related to operator method. I already have discussed operator method in detail in one of my previous videos. So here I will just be solving few more problems. In case if you are new to the channel, watch the videos in sequential order and subscribe the channel as well. So let us start the first problem. So here we have a non-homogeneous linear differential equation with constant coefficient. So the solution will be written as y is equal to complementary function plus particular integral. To find the complementary function, first we will write the auxiliary equation. So the auxiliary equation is m square plus 5m plus 4 is equal to 0. So this can be factorized like m square plus 4m plus m plus 4 is equal to 0. So the roots will be like, I can just do one more step, m into m plus 1 plus 1 into m plus 4 is equal to 0. Okay, so this can be further written as m plus 4 into m plus 1 is equal to 0. So therefore m is equal to minus 4 and minus 1. So the complementary function part will be c1 e to the power minus 4x plus c2 e to the power minus x. The more important thing is to find the particular integral, and that is why this operator method used for. So d square plus 5d plus 4, and that I need to operate on 18 e to the power 2x. So which result I have to use? The result that I have to use is 1 by fd, or if I operate it on e to the power ax, it should be equal to 1 by f of a e to the power ax, provided f of a is not equal to 0. So here also we are applying this. 18 being a constant will come out of operator, and in place of d, if I put a, I will get 2a square plus 5 into 2 plus 4 e to the power 2x. So you can see it will be 4 plus 4 8 and plus 10 18. So this whole thing here and this 18 will cancel each other. So what I will get is e to the power 2x. So the general solution is y is equal to c1 e to the power minus 4x plus c2 e to the power minus x plus the particular integral, that is e to the power 2x. So this is the first problem. Now quickly move to the next problem. So here again the solution will be written as y is equal to complementary function plus particular integral. Okay, as usual. And what is the auxiliary equation? So the auxiliary equation is m square minus 6m plus 9 is equal to 0. So that is nothing but m minus 3 whole square is equal to 0. So it will give me m is equal to 3 and 3. So the complementary function will be c1 plus c2x e to the power 3x. Okay, as you know, the case of repeated root. And what is the particular integral? So particular integral will be 1 by d square minus 6d plus 9, and that I will operate on e to the power 3x. So if you look at this, it is already obvious that if I put 3 here in place of d, it will become 0, because this expression has root 3 and 3. So in this case, as you have seen in the previous video also, what we do, actually it is 14 here also. So 14 I have to take out of the operator, and then we multiply it by x here in beginning, in before the operator, and we differentiate this term with respect to d. So we will get 2d minus 6 e to the power 3x. I repeat it, when this denominator becomes 0 by replacing d by a, then what we do, we multiply by x in the beginning, and then we differentiate this with respect to capital D. So that will give me 2d minus 6. So here we have the expression, that is 14x, and if I put d is equal to 3 here, you can see that it will again become 0. 2 into 3, 6, 6 minus 6 will become 0. So I will repeat the process, means I will multiply it by x again, and I will differentiate this with respect to d. So I will get 1 by 2 e to the power 3x. Now you can clearly see that there is no operator term left, and here it is 14 and here it is 2, so these two terms will cancel. I will get 7. So what I got is 7x square e to the power 3x. So what is the general solution? General solution is c1 plus c2x e to the power 3x and plus the particular integral, that is 7x square e to the power 3x. So we have seen two kind of problems. Now what we are going to do this to solve this problem, and to solve this problem it will be a slightly lengthier one, because it is going to involve a lot of different results, and I have deliberately chosen this problem so that you get the confidence that given any difficult problem also you should be able to solve. So without much delay, let's start. What is the process? The process is we write the general solution as y is equal to complementary function plus particular integral, right or not? To find the complementary function, we first write the auxiliary equation. Auxiliary equation here is 4m square plus 8m plus 3 is equal to 0. To save a space, I am writing horizontally, so it is 4m square, and you can write here 6m, you can write here 2m plus 3 is equal to 0. Finding the root is very important and you should be very careful. So I can take 2m common and I will get 2m plus 3, and from the next two term I can take 1 common, I will get 2m plus 3 is equal to 0. So from this I can take 2m plus 3 into 2m plus 1 is equal to 0. So the m values that we have got is minus 3 by 2 and minus 1 by 2. So the complementary function will be what? c1 e to the power minus 3 by 2x plus c2 e to the power minus 1 by 2x. But that was not my main aim. My main aim is to find the pi. So process of finding the pi will involve lot of steps, so be careful. So 4d square plus 8d plus 3 x e to the power minus x by 2 cos x. So the first result that we are going to apply is 1 by fd operated on e to the power ax into v, where v is a function of x, is equal to e to the power ax 1 by f of d plus a, and that is operated on v. So here this x and cos x both together will be taken as v. So I will be continuing here. Let me write e to the power minus x by 2 out, and in place of d replace 4d minus 1 by 2 whole square and plus 8 into d minus 1 by 2 plus 3, and it should be operated on x of cos x. So I can write it e to the power minus x by 2, and let us do the simplification. So 4 and d square minus d square plus 1 by 4 minus d. I hope you got it, because a square plus b square minus 2ab, and this will remain 8d minus 4 plus 3, and that we have to operate on x cos x. Okay, continuing here, I will get e to the power minus x by 2, and let us do the simplification. So you can see I will get 4d square term. So I got 4d square, and 4 into 1 by 4 I will get 1, and here we have minus 4 and plus 3, so this will cancel, right? So 1 plus 3 and minus 4 will cancel, and so, and from this I will get 4 into minus d, that is minus 4d and plus 8d. So what I will get is plus 4d, and that we have to operate on x cos x. Now I'm moving to the next page because there is not much space here. So you might have realized I am having some throat issue, but anyway, since we have started, we need to complete. So we have to apply the next result here, and I already have copied 4d square plus 4d x cos x. So the next result that we will be applying is a very standard result, 1 by fd, if I operate it on x into v. So here we have x and we have v as cos x. So here v is a function of x. So this is equal to x into 1 by f of d over v, and plus here we differentiate 1 by f of d, right, with respect to capital D, and that we operate on v. So if I continue here, I will get e to the power minus x by 2, and it will be how much? 1 by so x will be out, and I will operate on 1 by 4d square plus 4, and that I will operate on cos x, and plus here I will write d by dd of 1 by 4d square plus 4d, and that I need to operate on cos x. Okay, bracket is closed. Continuing, I will get what? I will get e to the power minus x by 2, and x is a x is as such d square. So the next result that we are going to apply is a very popular result, 1 by f of d square operated on cos ax will give me 1 by f of minus a square operated on cos ax, right? So in place of d square, we are going to put here, what is a? Here a is 1, a square is 1, so minus a square is minus 1. So wherever we have d square, I will put minus 1. So I will have 4d, and 4d square will become minus 4 and cos x. And here this will give me what? This will, if I differentiate this, d by dx of 1 by x I know is minus 1 by x square. So this will be minus 1 by 4d square plus 4d whole square. I am differentiating this with respect to capital D, and I need to differentiate using chain rule. So I will get 8d plus 4, and that I need to operate on cos x. So let us continue further. E to the power minus x by 2, and as you can see that here 4 is a constant, so I can write x by 4, and I will get d minus 1 here, right? So to make it d square, I need to multiply by d plus 1, and this will become d square minus 1. I hope you got this. 4 I already have common, so I am left with what? I am left with d minus 1, so I multiplied by d plus 1, and d plus 1 and d minus 1 will become d square minus 1 minus. If I look at this term here, again this 4d square, so d square will be replaced by minus 1, so this will become 4d minus 4 whole square, and here I can take 8d plus 4, and that we need to operate on cos x. Moving forward, e to the power minus x by 2, d square will be replaced by minus 1, so it is minus 1 minus 1 minus 2, x 4 into minus 2 will become minus 8, so I will get minus x by 2. D of cos x will give me minus sin x and plus cos x, right? And minus, to make a simplification, I can take 4 common. I will get 2d plus 1 here, and here if I take 4 common, 4 into d minus 1, so it will become 16 into d minus 1 whole square cos x. I hope you got what I did. 4d minus 4 can be written as 4 into d minus 1, so 4 square is 16 and d minus 1 whole square. Now for our convenience, I can write it e to the power minus x by 2. This minus can be taken common, so it will become x by 2, and here I will get sin x minus cos x. Now ideally I am done with the first part. Now let us complete the next part. So 4 2d plus 1, and actually 4 this can be cancelled, so let me remove this 4, and here I should write 2d plus 1, and I can write 1 by 4, right? And here I will have d minus 1 whole square, so that will become d square minus 2d plus 1, and that we will operate on cos x. Now we don't have any more space, so we need to move to the next page. Okay, so moving forward, I already have copied the terms over here. So e to the power minus x by 2, x by 2 sine x minus cos x. So I write sine x minus cos x. Okay, and then again this d square should be replaced by minus 1, right? So this will be minus 1 and this will be plus 1. Okay, so minus 1 and plus 1 will cancel. Let me write, otherwise there may be a scope of confusion. So I write 2d plus 1, and here we will have for d square I will write minus 1 minus 2d plus 1, and we will operate it on cos x. So now you can see this minus and plus will cancel, right? So this plus 1 and this minus 1 is cancel, and we have a minus sign and we have a minus sign here. So I will get what? I will get e to the power minus x by 2 x by 2 into sine x minus cos x, and minus 1 by 4 and plus this minus 2, it will become plus 1 by 8, and I can write it 2d plus 1 into d divided by it is already one, I already have taken this minus 2 with this 4 8, so I am left with d, so it will become d square. I multiplied by or operated d on both numerator and denominator. So we are almost in the very final stage. So e to the power minus x by 2 sine x minus cos x. I feel I am very low with energy today. Anyway, why should I low with energy? I am speaking faster. So 1 by 8, d square will become minus 1. So I am writing minus 1 by 8, right? And this is 2d square plus d. So let me write one more step. Students should not get confused, so writing more steps should not be a problem. The final aim is to make a student very clear about it. So e to the power minus x by 2 into x by 2 sine x minus cos x. I am just copying the first part, and here this d square become minus 1, so this become minus 1 by 8. So I am writing minus 1 by 8, and now d square of cos x means derivative of cos x twice with respect to x. So first if you differentiate, you will get minus sine x, and then you differentiate, you will get minus cos x. And I think you are also smart enough to understand that if you operate d square on cos ax, the d square is replaced by minus a square, so it will become minus 2 cos x, and d of cos x will be actually minus sine x. So we can now complete this step. So I will get e to the power minus x by 2 x by 2 sine x minus cos x, and here I can take this minus common, so this will become plus 1 by 8 2 cos x plus sine x, right? So this is the end of the story. This is the PI. It has taken a lot of time and effort, but I hope you are clear about the process. Okay, so I think there is a small mistake that I have committed, and let us correct that mistake. When I replaced this d square by minus 1, it became minus 2, right? And this is 4, so this term will not be 2, this term will be 8, right? So in all other it should be 8. So this is a small mistake. 8 8 8 8. Okay, so let me actually write the final one very carefully. So all this actually becoming 8. So let me write 8 8 8 8 8 8. I was careful, but still you noticed that sometimes the mistakes may happen. So this was basically 4, right? So 4 into minus 2, this should become 8 and 8. So replace this. So 8 and then 8. Okay. So I hope everything is clear now and you have understood the process, and if you are watching the video carefully, you might already have realized that I have made a mistake, but in the end it's all good, corrected. Okay. Okay, so now let us solve this problem here. So what we have to do, so what is the solution? So solution is y is equal to CF plus PI. So to find CF, we have to write the auxiliary equation. So the auxiliary equation is m square minus 6m plus 13 is equal to 0. So that will give me m is equal to minus b, that is 6, plus minus b square, so minus 6 square is 36, minus 4 into 1 into 13 by 2a, so 2 into 1. So it will give me 6 plus minus 36 minus 52, that is minus 16 by 2. So it will give me 6 plus minus 4i by 2. So 3 plus minus 2i. So imaginary pair of roots. So complementary function is e to the power 3x c1 cos 2x plus c2 sin 2x. Let us find the pi. So pi will be 1 by d square minus 6d plus 13, and we are going to operate it on 28 e to the power 2x sin 2x. So as we already have, this is e to the power x into v, so 28 constant out, e to the power 2x is also out, and this d will be replaced by d plus 2. So d plus 2 square minus 6 into d plus 2 and plus 13, and that we will be operating on sin 2x. So continuing here, 28 e to the power 2x, and you differentiate it, so d square plus 4 plus 4d, a square plus b square plus 2ab, and minus 6d minus 12 plus 13 over sin 2x. So this is equal to 28 e to the power 2x 1 by d square as such, 4d minus 6d, that is minus 2d, and 4 plus 13. So 4 plus 13 is 17, 17 minus 12. So 17 minus 12 is plus 5, that I operate on sin 2x. So now I have to move to the next page. So let me continue over. So continuing over here, I already have copied this term here, 28 e to the power 2x 1 by 2 d square minus 2d plus 5 over sin 2x. So now I have to apply the sine result, that is 28 e to the power 2x, and in place of d square I have to put minus a square. So it will become minus 4 minus 2d plus 5 sin 2x. I hope by now you are confident about the process. So next we have 28 e to the power 2x, and we get what? We get 1 minus 2d, and that we have to operate on sin 2x. So I will write 28 e to the power 2x and 1 plus 2d, and then 1 plus 2d and 1 minus 2d will be 1 minus 4d square, that we have to operate on sin 2x. Now again d square will be replaced by minus 4, so 28 e to the power 2x 1 plus 2d and 1 plus 4 over is applied on sin 2x. So now 28 by 5 e to the power 2x and sin 2x as such, 1 into sin 2x, and derivative of sin 2x, d of sin 2x is 2 cos 2x. So 2 into 2, that is 4 cos 2x. So that is our pi. CF we already have calculated, so we can write the solution as CF plus pi. So let us do this problem, and this is the last problem, problem number 5. So here also, how will you write the solution? Y is equal to CF plus pi. What is the auxiliary equation? The auxiliary equation is m square plus 25 is equal to 0. So that will give you m is equal to plus minus 5i. So the complementary function part will be c1 cos 5x plus c2 sin 5x. And how I will find the particular integral? Particular integral will be 1 by d square plus 25 operated on 9x cube plus 4x square. So this is a polynomial function, and as you know that in case of polynomial, what we do, we use the binomial expansion. So we take the lowest degree term common, means I take 25 common, and then I write it 1 by 1 plus d square by 25, and that we need to operate on 9x cube plus 4x square. So I can write it 1 by 25, and here I will write 1 plus d square by 25 to the power minus 1, and I need to operate on 9x cube plus 4x square. Now 1 by 25, 1 plus x to the power minus 1. So you remember the result, it is 1 minus x. So 1 minus d square by 25 plus x square. So that will be d to the power 4 by 625 and minus and so on. And we have to operate it on, there is no space, so I am writing here 9x cube plus 4x square, right? I hope it is the same thing. So but one thing you notice that it is a polynomial of degree 3. So d to the power 4, if I operate on a polynomial of degree 3, will give me what? It will give me 0. So actually this term I have just written for you to understand. Even this term is not needed, and any other higher power of d is also not needed, because if you have a polynomial of degree 3, if you differentiate it 3 times you will get a constant, 4th time you will get 0, 5th time you will get 0, and after that also you will get 0. So you have to basically write 1 by d 1 minus d square by 25, and that we have to operate on 9x cube plus 4x square. So how do you operate? 1 by 25 is as such, 1 into 9x cube plus 4x square, and minus 1 by 25 again, right? I hope it is okay. If I have taken 25 common, it is 1 by 25, and it is d square by 25. Okay, fine. Now d square of 9x cube. So if you differentiate 9x cube plus 4x square once, you will get what? You will get 9 into 3, 27x square plus 8x. And if you differentiate this again, you will get 54x plus 8. So you will get 1 by 25 into 54x plus 8, and then the bracket is closed. So basically you are getting what? You are getting 1 by 25 into 9x cube plus 4x square minus 54 by 25x minus 8 by 25. And this is your pi, and this is your CF. So general solution is CF plus pi. So I hope I have taken some good problems here in this video, and you have followed it. In case if you think that there is any doubt or confusion, let me know through the comment section, and share this video with all your friends, and keep watching. That's all from my side. Have a very nice day.